All right, we are live. Can everyone say hi if you're here? Okay, is anyone here? This is going to be a very short fit block if no one shows up. Okay, so the only question I have that's been sent to me by a couple of students, so I'll discuss that here, is question 4 of the computer simulation assignment, the lab block here. And so question 1 was just adding the positive and negative charge. We had the fields around there. Question 2 and question 2 was doing up the 2 parallel plates. Now what I've done over here is I've done this myself, and I've also included the different values here, so you can see it goes from 60 or negative 70 volts over here on the left hand side, labeled 69.1, and on the right hand side 70. So these are roughly in 10 volt increments for this video here. Question A was drawing the lines. Your lines should look something like this for your drawing. The field lines, I should say, are these white arrows. And you can see that these white arrows, they are going to point from the positive side to the negative side. And so, yeah, that's going to be the field strength here. It's going to be pointing from the positive to the negative. And you'll notice when you have a row of charges like this, not just one single charge, that the field lines between those two rows should be fairly flat. So they should be, I should say, perpendicular to the plates, or they're in parallel lines moving towards from positive to negative. So that was fine. We had the field lines drawn, no problem. The equipotential lines, no problem. We've put the 2 plates here. So on your own drawing, you will have your own set of lines. So this might be your 70, 60, 50, 40, etc., etc., etc. You're going to have these lines here. And so wherever you've drawn them, so let's say you wrote this as negative 70 volts. Well, one thing that I was missing, and I did make a note of it on Google Classroom on the assignment, I said we have to assume something here. Sorry, this should be positive 70 volts. We have to assume something here, and the assumption that I asked you to make was that this plate is at, say, negative 100 volts. So question C talks about comparing the motions. Well, you have to just think about the amount of force being applied to these when one has 3 charges and one has 1 charge. Well, if we look back at our square here, so we have potential energy, fields, and force. And these ones are Q, these are Q1, Q2, these are over R, or these are over R squared. Now this is for radial charges, this over R or over R squared, but the relationship between these is still true. So force times distance or times R would give you potential, and vice versa. And then over here, field multiplied by Q gives you force, force divided by Q would give you the field strength. So in this case here, this one has 1 charge, this one has 3 times as much charge. So how is the force going to compare between them? Also, we also said here that it has 5 times the mass. So if you increase the mass by 5 times, how does that affect its acceleration? So I'll leave that to you to see. No one asked me about that. And lastly is question D. This is the one that a lot of students had trouble with. Now, once you assume that it is from whatever point your line is, maybe this is the where you drew the plus 70 line, maybe this is where you drew the plus 50 line. I don't know exactly how you've done your drawing, But wherever it starts from to wherever it finishes, this is the amount of potential difference. So in this case here, if you drew this line as 50, it's going from 50 to negative 100. Well, the potential difference is going to be V final minus V initial, so this is going to be negative 100 minus 50 or minus 70, whatever that is, and that's going to equal negative 150 in this particular case. So you can think of it this way. If you're thinking about altitude, let's say you're up at the top of a ramp. Then if you're at the top of a ramp, then let's say this altitude here is 50 meters and this is 0 meters. The potential difference would be you're going from 50 meters to 0 meters. So if you know this is you can think of the potential as G times H, and then if you want the potential energy, you just multiply that by the mass, if we're thinking back to gravity. And I also just want to highlight here something that hopefully you're picking up on yourself. I've drawn this from, I said it was 50 to 100, or sorry, 50 to 0 meters. What if I said this was starting at 100 meters and this was finishing at 50 meters above sea level? Well, the difference there is still 50. What if I said that this was starting at 25 meters above sea level and this is finishing at 25 meters below sea level? Again, still 50 meters. Sorry, I realize that's not on screen. So still going to be a difference of 50 meters, regardless of how you look at that. So the potential doesn't matter in terms of what the initial and final is. The potential difference is just the difference between those two values. So now if we have our potential, we can figure out our potential energy by just multiplying it by Q. So if the potential is 150 or negative 150, that means the potential energy decreased by 150 times Q over on the right-hand side. So if I want to know the work done, it's just the potential difference multiplied by Q, and we're given the value of Q below. And so again, this here is going to be a negative number because the Q is positive and the potential difference is negative. So what that means is my potential energy has gone down. Now, if my potential energy has gone down, what does that mean for calculating the velocity? Oh, hi Pasha, I see that you're here now. So what does that mean for calculating the speed? Because the question here is asking what's the final velocity? Well, what we know is that you lost 150 volts multiplied by this charge. That's going to tell you how much potential energy I've lost. And the question here is asking you how much energy you've gained in a sense. So if we're asking you what the final velocity is, then essentially we're in a way asking you what is the kinetic energy. And we should know that the change in potential is going to be equal to the negative change in kinetic. If you lose 20 joules of potential by dropping something or letting something fall from a positive plate to a negative plate, then that means that you're going to gain the same amount of kinetic energy. So hopefully that gives you enough to answer this question. If that doesn't, then please feel free to email me any more questions. And, oh, hi Aaron, good to see you. And do either of you have any questions for me? I see that we've got 5 people watching the video now. So do any of you 5 have a question that you'd like me to answer? If you came in the middle of question D, then feel free to watch the video again afterwards. And bear in mind the questions can be about the assignment or they can be about these questions up here if there's anything you're unsure of. So how is everyone doing, by the way? Okay, well, it seems like there are no... I'm good, thanks for asking. Thank you. And do you have any questions? Because I think I'll wrap this up then if there's no other questions. Okay, I guess that is that. So a very short live stream. If you have any other questions, please feel free to email me, and yeah, I'm happy to help anytime. All right, take care, everyone. Hopefully you're doing well. Thank you.